Hello and welcome to The Explainer. Today we're plugging into a really huge topic, how artificial intelligence is pretty much completely rewiring our electrical grid. It's a quiet revolution, but it's happening every single time you flip a switch. All right, let's get right into it. So to really get what's happening, we have to start with this basic question. Think about it. Our entire world runs on electricity, but the system delivering it was built for a much simpler time. So how do we keep the lights on today with electric cars, massive data centers, and this huge demand for clean energy? That's the fundamental puzzle we need to solve. And this slide, wow, it just lays out the massive shift that's happening. The old grid, it's basically a one-way street. A big power plant sends electricity down the lines, and it ends up in your home. It's super centralized, which means if one big part fails, poof, the lights go out. But the new grid, the smart grid, it's a completely different beast. It's a two-way network. Power can actually flow from your neighbor's solar panels back to the grid. It's decentralized and it's built not just to react when things break, but to actually predict problems and heal itself. So what's the magic ingredient here? What's the secret sauce that makes this new grid even possible? You guessed it. It's artificial intelligence. AI is the brain that's turning our old, clunky infrastructure into a smart, resilient system that's ready for the 21st century. Now look, it's not just me saying this is a big deal. Our source material puts it perfectly, quoting a 2025 paper. AI represents a paradigm shift comparable to the introduction of computing and the internet. Let that sink in for a second. We're talking about a change on the scale of the internet itself. This is huge, and it's not some far-off future thing. It's happening to our power system right now. Okay, so to really wrap our heads around this, we need to quickly understand what we even mean by AI here. Let's take a quick peek under the hood at the brains behind this whole operation. At its heart, AI is really just about building systems that can do things we normally think require a human brain. Things like learning from experience, thinking through a problem, and making really complicated decisions, but doing it at a speed and scale that, honestly, no human ever could. And it's super important to know that there are two main flavors of AI doing the work here. First, you've got narrow AI, which is basically traditional machine learning. Think of it like a specialist. It's trained to do one thing, but do it incredibly well, like predicting exactly how much power a city will need tomorrow. Then you've got generative AI. This one's the creator. It doesn't just analyze what's there, it creates something brand new, like designing the most efficient layout for a new part of the grid. You absolutely need both. But how do these things get so smart? Well, that's where deep learning comes in. It's not a totally separate category. Think of it more like a supercharged, souped-up version of machine learning. It uses these really complex webs called neural networks, kind of modeled after our own brains, to find tiny, hidden patterns in just massive amounts of data. This is the tech that lets an AI predict a power outage or a wind farm's output with just jaw-dropping accuracy. Okay, that's enough of the tech speak. Let's get to the good stuff. How is this AI-powered makeover actually upgrading our energy infrastructure in the real world? The cool thing is, AI isn't just touching one part of the system. It's woven into the entire journey our electricity takes. It starts right at the beginning with planning the whole system. Then it's there second by second, operating the grid. Then it's distributing the power, and finally, it's even helping manage how we use that power in our homes and businesses. Let's walk through it. So, let's start with operations. Right now, utilities are using drones with AI vision to fly over hundreds of miles of power lines, spotting tiny problems before they become big ones. And if a tree branch does fall and knock out a line, AI can find the exact spot in seconds instead of hours. The source material even points to Hydro-Quebec using deep learning to predict energy demand with unbelievable accuracy. So what does that all boil down to for you and me? It's simple. Fewer blackouts. And when they do happen, the lights come back on way fast. All right, now let's bring it even closer to home, to your local neighborhood grid. Remember that two-way street we talked about? AI is the traffic cop that manages all that energy flowing from rooftop solar panels and home batteries. It can also spot weird patterns in the data that might point to energy theft or failing equipment. And by constantly fine-tuning voltage levels, it cuts down on wasted energy. And again, what's in it for you? A much more stable grid and, since less energy gets wasted, the real potential for a lower electricity bill. And all of this, really, It builds up to one of AI's biggest, most critical roles, making the dream of a renewable energy future actually possible. It's all about powering a greener world. But there's a huge catch, right? We all know it. The sun doesn't shine at night, and the wind doesn't always blow. So how on earth do you build a reliable grid, one that's on 24/7, when your main sources of power are just fundamentally unpredictable? And this chart just shows you the problem perfectly. On one side, you've got solar and wind power, which jump all over the place depending on the weather. On the other side, you've got our demand for energy, which is pretty steady and often peaks in the evening right when solar power disappears. See how the peaks and valleys just don't line up? That mismatch is the core headache of the clean energy transition. And this is where AI comes in and saves the day. It's like the ultimate orchestra conductor for the grid. It takes that unpredictable mess and turns it into a perfectly optimized system. AI models look at weather data to predict wind and solar output with amazing accuracy. Then, they conduct this complex dance between the solar farms, the wind turbines, and giant battery systems, charging the batteries when power is cheap and abundant, and then releasing it when demanded high. And the end game here, it means we don't have to fire up those old, dirty fossil fuel plants nearly as often. It's a total game changer. So where does this road lead? What's the next chapter for AI and our power? Let's take a look at energy's automated tomorrow. The ultimate goal, the big vision, is a grid that's pretty much autonomous. We're talking about a system that can diagnose its own problems, automatically reroute power around a failure, and basically heal itself, all with very little human help. And this isn't science fiction. It's the logical next step from everything we're seeing today. Of course, you can't have this level of high tech without the rules catching up. That's where this idea our source brings up, Regulation 4.0, comes in. It's the idea that our policies can't be static and slow anymore. We need rules that can think and adapt, using real-time data to evolve just as fast as the technology itself. And this isn't just some abstract idea. The potential is global. The source material highlights that a country like Brazil, with its huge base of renewable energy, is in a perfect spot to become a world leader in applying this tech. It's a great reminder that this isn't just happening in one place. Any region with great natural resources can use AI to completely transform its energy future. And that brings us to one final, really important thought. We've talked about a grid that's more efficient, more reliable, and greener. But as we build this incredibly intelligent system, we have to ask ourselves a crucial question. How do we make sure that all the benefits, the lower costs, the cleaner air, are actually shared by everybody? How do we make sure a smart grid doesn't leave behind the very people already struggling with energy poverty? You see, making the grid smarter is the technical challenge. Making it more equitable, that's our human challenge. Thanks for joining us on The Explainer.